This area. If your Vy is in this direction, I will draw the Q for you guys to make your. I'll draw the Q this way. Okay, so these are all your Q. Okay, top correct or bottom correct?
Top.
Top. Neither. Top correct or bottom correct? I go. It has to be one is correct. Top because rule number 5. Okay. If we look at the bottom one, which rule has it broken? Okay, so I zoom out the rules. Okay. It has broken rule number 4. Yeah. So rule number 4 is broken. Okay. It's wrong. Okay, rule number 4 is wrong. If we look at the one on top, any rules that are broken? First moment of area did not cross. Or there's another option. Sorry, there's another option. I did not give you another option. There's another option. I'll draw another option for you.
But top was still answer, right?
Huh? I give you another answer. Or is it this one?
Top.
The top one, right? Now, why the last one I've drawn is not correct? Which rule has it broken?
Could you go up, sir? I can't see the rules.
So which rule did it break? It broke rule number 3. Right? Rule number 3 says analysis direction will start from what? Y max. Yeah. Tyron, you're right. Right?
Is that min or max, sir?
Huh?
That looks like Y min.
Right? Yeah. Okay. So you can see now, right? Without all these rules, you are game over, you know. You have to. I just give you an example why these rules are so straightforward. So the correct reason, the correct area to consider is this area. Okay. It did not. It satisfied rule number 1, rule number 2, rule number 3, rule number 4, rule number 5. This is correct. That is the area of concern. That is why this topic, okay, formula is easy. Formula is really, really easy. Why is it difficult? Because of the analysis. Okay, it's because of that. Now, last one. Okay, last one. We're still going to do the same. Okay, we're still going to do the same. Okay, last one. I'm going to put it independent. Okay, I'm going to put down here. What if now what if now I want to find over here? Oh, that is my point of interest. Okay, that is my point of interest. So which area do you take?
The bottom part.
The bottom part. And what does it look like?
Just
looks like a square, right? Yep, it just looks like this. This is the area. That's it. Okay. Now the other question is this. I have one more. I have a lot. What if now? Okay. I want to find the stresses at this point. Exactly at the centroid. Which one do I take? Now for this one, Michael, Matthew, or Mike. Hey?
We can take either one.
Top yeah. You can take top. You'll get the answer. Or you can take bottom. Okay, bottom. Okay. If you're interested in this point, bottom. The answer will be exactly the same. Because the centroid at the centroid, the area, right, at the top and the bottom are the same. Yes or no?
Yes.
Okay.
And sir,
And
also taking the bottom one is better, right? Because if there's only one rectangle. But
yeah, one rectangle is easier, but you have to have the confidence. Okay. A lot of
yeah,
students are worried. Top, bottom, bottom, top. Should I go from top or should I analyze from bottom? Okay. That is where it's confusing. So that's why I just show you how critical these 5 rules are. The top 4 are more critical. The 5 is a special case. Okay. Okay. Now we are going to do this very long example. Okay. This example will take about an hour. Okay. But this example has a lot of layers. Okay. And has what we have taught since 9 o'clock this morning. Okay. And this is a critical example. Okay. As I said, this topic, yeah, you can see now, right? It's a lot of rules. So it's like electrical engineering topic. Okay, you cannot see current, right? But you have to trust V is equal to IR. You have to trust it. Okay. So that's where you have to apply the rules. Okay. For your information, I'm a lawbreaker. I don't like to apply rules when I was young, but when I grow older, I have to. Okay. Like for example, if I get another speeding ticket, I need to go for driving school because I don't obey rules. Okay. Right. So you will see this example on Avenue to Learn. Okay, so this is example number 1. This example you're going to learn a lot of this you are going to learn a lot of layers of solving a problem like this. A lot of layers. Okay, what do I mean? A lot of layers. So we are going to draw. I'm going to tell you what we're going to learn from here. Okay, so we're going to draw our free body diagram, which you all know very well. Then after that, we're going to calculate or determine reactions at point A and point B. Okay. And then we're going to draw the shear force diagram. To determine Vmax. Okay, to determine Vmax. Then after that, we're going to calculate the shear stress. Shearing stresses at point A, small a, and shearing stresses at small b. Okay, but before we can calculate the shearing stress, we need to do other stuff. Okay, what are other stuff? We need to determine the centroid position. Okay, we need to calculate second moment of area. Okay, you can see what you will learn from here, and then you will need to define your first moment of area. And then you then from here, then you can find your shear stress at point A and your shear stress at point B. Okay, so there are a lot of steps down here. Okay, so let's look at this structure. So this structure is a simply supported structure. Okay, and you have a point load acting exactly in the center, which is 180 kilonewton. So we're going to find the shearing stress at point A and point B. A lot of times students make a mistake and they assume Okay, they assume V max to be equal to 180 kilonewton, and this is wrong. Okay, this is wrong. Okay, you cannot, oh, that's the number I'm given. Okay, we are 180. No, this is wrong. Okay, you don't make that sort of assumption. Okay, so before you draw, you draw your transformation first. Okay, so this is my X and Y. This is my rotation about Z. And for this case, this will be my Y. This is my Z. This will be my rotation about X. Okay. So on the right is the cross-sectional view. On the left is AB. So first thing that comes to our mind is why they did not give this distance. Okay. So first thing I said, oh, n, why n, but yeah, it is at your mind, but don't just get bothered by it until like you don't do anything. Okay. So you start. Okay, so you start. So we are going to construct our free body diagram. Oh, some of you are copying down here. Okay. Okay. So this is your X, Y, rotation about Z, and then this is our beam. Okay. So you know that you have a point A down here, and you have point B down here. Right. So you have AY, you have BY, and you have a load coming down at 180 times 10 to the power 3 Newton. Okay. So we are going to carry out static analysis. Okay. I'm going to take some mention about moment, about my z-axis A at point A. I'm going to take moment about point A. So I'm going to take moment about here. Everything is equal to 0. So you have minus 180 kilonewton, and then the distance is 0.5. Okay, and then you have plus by by, and the distance is 1. The whole thing is equal to 0. Let me see, is it 1? Yep. So by is equal to 90 times 10 to the power 3 Newton, and it's positive, means the assumed direction is correct. Okay. Then the next one, you go summation about forces. In the y direction, positive is going up. So you have AY minus by 180 times 10 to the power 3 plus by 90 times 10 to the power 3. The whole thing is equal to 0. You realize that AY is equal to BY carrying 90 times 10 to the power 3 Newton load. Okay. Then the next thing that we're going to do, we're going to construct our shear force diagram. Okay. So our shear force diagram. Oh, sorry. So this is our X, this is our V, and this is our positive 90 times 10 to the power 3 Newton. And over here, this is our minus 90, this is 0, and this is our 1 meter, and this is our halfway. Right. So now we construct our shear force diagram. So our shear force diagram from point A where the load is applied, it go horizontal, right? Then at this point, it will go down by 1/8